Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about binomial distribution real life examples. In our previous class, we clearly discussed about what binomial distribution means. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so our first example is from the previously collected data. It says that 30,000 tests conducted on coronavirus. Out of 30,000, 18,000 are positive. Means it says that 18,000 persons got coronavirus out of 30,000 tests. And they are going to ask you, today we are doing 10 tests. What is the probability that at most 8 patients will have virus? At most 8 patients will have virus. From this we have to understand that you can have 0 patients, you can have 1 patient, you can have 2 patients, at most you can have 8 patients. What is the probability that you are going to have that at most 8 patients will have the virus? First we have to understand from the data, is it applicable to binomial distribution? That is the point we have to understand from the data. Yes, it is applicable to binomial distribution. How it is applicable? Let's try to understand. From this previously collected data, they have given the probability of getting a coronavirus to a person. How you know that? Out of 30,000 tests, 18,000 are having positive. Means 18,000 by 30,000, we will get 0.6. Means a 60% chance of getting a coronavirus to a person. That is what this data says. So P value has been provided. Today we are doing 10 tests. N value has been provided. N is 10 value. And what is the probability that at most 8 patients? X value has been provided. If X value, N value and P value provided, we can apply this to binomial distribution. Not only that, you have to check the remaining conditions also. See, the point to understand, each test is independent of each other. These are the conditions we discussed in our last class. Yes, testing you is independent of testing me. So each test is an independent of other test. That is the point you have to understand. That is what binomial distribution says. Each experiment should be independent of other. Yes, here it is independent of other. Next point is test result says either positive or negative. Means only 2 values. It is a Bernoulli test, success or failure. Now we have made 10 different tests. Means if Bernoulli experiment is repeated n times, we can apply binomial distribution. That is what we have discussed in our previous class. So we can convert this example into binomial distribution. So the P value is 18,000 by 30,000, that is 0.6. This is given from the data. N is equal to 10. We are going to take n tests. Out of that, how many X value is 8? At least 8. Don't forget that, at least 8. Our binomial equation is NCX, probability is 0.6. 1 minus P means 0.4 power of n minus x. So this is our distribution. If you do 10 tests, you can have 0 persons having coronavirus, 1 person having coronavirus, 2, so on up to 8. We have to do the cumulative sum, cumulative distribution function. That's why in real life cumulative distribution function is very important. Previous first examples when we discussed about probability distribution, so we explained what's cumulative distribution function for a given discrete probability distribution. So we have to do that cumulative. We need cumulative distribution function sigma all x up to 8. Up to 8, we have to summation of all the probability values. This is probability mass function for a binomial distribution. So adding all up to 8 is difficult to do the calculation. We have to find NC0, we have to find NC1, 2, so on up to NC8, summation of all those. Instead of that, adding all these probabilities, here we need to write the probability values. Instead of that, adding all the probabilities values, we will get 1. Sum of all the probability values is 1. 1 minus NC9, NC10. That gives the same value. We are going with the other way. 1 minus, we go with 1 minus 10C9, 0.6 power 9, 1 minus 0.6 power 1 plus 10C10, 0.6 power 10 multiplied by 1 minus 0.6 means 0.4 power 0. If you calculate this is what the probability value you will get. You do the calculation. We are not doing the calculation here. So you try it on your own for better practice. Coming to the second question. So based on this, you have understand this example. We'll go a little bit fast for the second example because the concept is well known. So that's why we are going fast. The probability of a man hitting a target is 1 by 3. It was given that the probability of a man hitting the target is 1 by 3. First question is very easy. You have to concentrate much on second question. If he fires 5 times, probability value is given. What is the probability of hitting the target at least twice? These are independent events. Yes, shooting 1 time is independent of shooting second time. And it is Bernoulli experiment. He may hit or he may miss. We can apply binomial distribution for the first question. Second question also, how many times? So this is the question you have to concentrate much. Think about this question as much times as you want, because most of the times we will apply this in our real life. Not only in this example, you try to elaborate where we can apply binomial distribution in our real life examples. This question is very much used. How many times must he fire? So how many times must he fire so that probability of his hitting the target at least once is more than 90%. So this is very important to understand. So coming to the first question, probability of x greater than or equal to 2. This is the question they have asked. Greater than or equal to 2 means here probability value is given 1 by 3, n value is given, he is shooting 5 times. What is the x value is given? Twice. So probability of x greater than or equal to 2. Instead of finding this, we can go with 1 minus probability of x less than 2. Summation of all the probabilities is equal to 1. That's why we are going with other way. It is easy for the calculation. 1 minus 5c0, 1 by 3 power 0, 2 by 3 is the miss probability. This is hit probability, power 5 plus 5c1, 1 by 3 power 1, 2 by 3 power 4. If you find this, the final value is 0.5391. This is the probability he is going to hit for the first question at least twice. Coming to the second question, probability of x greater than or equal to 1 is greater than 0.9. From the question it was given that how many times must he fire so that probability of his hitting the target at least once is more than 90%. So that's why probability of x greater than or equal to 1 greater than 0.9. From this, if you want to find the probability of x greater than or equal to 1, we can convert this into 1 minus probability of x is equal to 0 greater than 0.9. 1 minus, if you find this probability of x is equal to 0, nc0, 1 by 3 power 0, 2 by 3 power n. We need to find the n value greater than 0. nc0 means 1. So 1 minus, if you calculate, if you substitute 1 by 3 power 0 means 1, nc0 means 1, 1 minus 2 by 3 power n less than 0.9. For which n value it is going to satisfy. You keeps on trial and error method. N is equal to 1, n is equal to 2, we will get 1 minus 2 by 3 power 6 equal to 0.912, which is greater than 0.9. So n is equal to 6. At least he has to fire 6 times for the given question. We are finding the n value. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.